sort of things, that's at the user interface. We're looking at calculations now. So again, we're down in the business logic. Okay, now the point, I'm going to throw a little terminology at you, and you're going to wonder why. At first, you might say, "Ooh, wow, this terminology, I don't like this. It's kind of complicated." Now, let me explain why, and possibly give you some motivation. There are basically three places where you can read up further on domain analysis. One is my book, Pragmatic Software Testing. There are two other books. One is called Software Test Techniques by Boris Beiser, and the other is Testing Object-Oriented Software by Bob Binder. Now, Boris and Bob are friends of mine. I like them. They're great guys. But I'll tell you, they write. You got to work. You read their stuff. You got to work. And so when I wrote Pragmatic Software Testing, I was trying to sort of split the difference by writing it in a way that was more accessible than I thought Boris and Bob were. But at the same time, if you read Boris or Bob's work, having read my work, you'd be able to, it would help you get there. So I did decide to include some of the concepts that they talk about, just so that if you decide to take this a little bit further and go beyond what I describe in Pragmatic Software Testing and move on to reading Boris's book or Bob's book, that you'll be able to follow it. And so this is where we get into these different, what they call, what Beiser referred to as different domain test values. So he came up with 4 possible types of domain test values. There's the on value, the off value, the in value, and the out value. Okay, now, each of these has very precise definition. An on value is, get the highlighter going here, a value that is on a domain boundary, which may be inside or outside of the domain. Okay, now, the case of the frequent flyer example that we just looked at, the domain is of infinite thinness because it's a line. It's not an area. It's not a volume and so forth. So I mean, you're either in one domain or you're in another. So that every value is in a sense a boundary value because you're one discrete step away from being in another domain. So 1 is an on value for platinum, the value 1 that was shown on the previous page. 2 is an on value for gold, 3 for silver, and 4 for none. Let's go back and look at that. Oops, this way, please. Okay, see 1 here. Let's highlight 1. It's an on value for platinum because there is nothing in between the space here between platinum and gold. You can't be in this area here. I mean, you're either on one of these lines or another, right? So this is empty space in here. Similarly, 2 is an on value for gold because we're on the boundary. If we weren't in gold, we'd be either in platinum or in silver. And then 3 is an odd value for silver. If we weren't in silver, we'd be, if we had a few more miles, we'd be in gold, and if we had less miles, we'd be in none. And then 4 is an odd value for none, because if we had more miles, we'd be up in silver. Okay, so now, so that's the on value. It's right on the boundary. Could be inside or outside of the domain. In this case, the ons are inside of the domain. Now, off. An off value is a value that is just off of a domain boundary by the smallest recognizable amount, and it is outside of the domain. So 1 is an off value for gold because we have the step between platinum and gold is 1 step, so it's the smallest recognizable discrete difference in terms of these levels. And so we we're right off of gold, and we happen to be on platinum, right? So notice we're reusing value 1 here. 2 is an off value for platinum because we're just below the number of miles needed to be platinum. If we were in the next tier up, we'd be in platinum. 2 is also an off value for silver because we're just above silver. 3 is an off value for gold because we are in silver, right? If we had more miles, we'd be in gold, and if we had less miles, we'd be in none. So that off value there. And then 4 is an off value for silver because we're just below the number of miles needed to jump into the silver status level. Okay, so ons and offs. We have ons and we have offs. Now, there are also 2 other types of domain test values that, if present, need to be tested. There's the in value and the out value. Now, in value is a value that is inside the domain, but it does not qualify as an on or an off value for that domain or any other domain. An out value is a value that is outside of the domain and is not an on or an off value for that domain or any other domain. Now, in case of the frequent flyer example that we just looked at, there are no values inside of the domains or outside of the domains because, as I showed, you're either in one line or you're in another, so you can't be in between. But you're going to see in just a minute a way in which you could indeed be in between, which is this one here. All right, now, those of you who took physics or other advanced mathematics in high school and college, this is not too complicated. For those of you who didn't, I'm going to try to simplify this a bit. Imagine that you're trying to test a anti-ballistic missile system. Okay, now in such a system, what you are very interested in is trying to hit a very large falling object. Basically, that's what a incoming ballistic missile would be, right? Large falling object. At that point, the boost phase is over, so it's just it's falling. We're not talking about a rocket-propelled grenade here. We're talking about a ballistic missile. In order to shoot at anything that's moving, you don't shoot at it, you shoot in front of it. And so you need to know where in front of it to shoot. Now, the conservation of momentum says that the vertical distance, that the forwardness with which it's moving is changed only by air resistance. But the vertical speed with which it's falling is changing as it's falling because it's being acted on by gravity. So if you're going to try to predict how far in front of this falling ballistic missile you need to shoot, you have to decide whether you need to take into account the acceleration of gravity, or can you just assume that for the time it's going to take for your whatever it is to get there, laser beam or targeting missile or whatever, that the effect of gravity will be insignificant in terms of its overall increase in speed. So let's say that what we do here is we measure the velocity of this falling thing with radar, and we then want to determine, we want to basically estimate where this thing is going to be, where this missile is going to be. And again, we're going to recognize that there are 2 domains here, either the domain where we need to take gravity into account, or the domain where we're going to say, well, let's just assume that this continues to move, roughly the same speed. Okay, so if the time required from shooting the radar out and getting the signal back is less than 1 millisecond, we're going to ignore acceleration of gravity as domain 1. And if the time is greater than or equal to 1 millisecond, we're going to say we're going to have to include gravity in the calculation. Okay, so if we're going to ignore gravity, then the estimated current vertical position